Before we begin, a quick and important notice. The information provided in this video is for educational and informational purposes only. It is not a substitute for professional advice from a licensed, insured, and qualified commercial plumbing contractor. Every commercial property is unique, and you should always consult with a certified professional to assess your specific situation and ensure compliance with all local, state, and federal building codes and regulations. Imagine this. It's 6 a.m. Monday morning. You're the first one to arrive at your business, your restaurant, your retail store, your office building. You put the key in the lock, turn it, and push the door open. But before you can even reach for the light switch, you hear it. The sound of a gentle lapping wave. And then you feel it. A cold, squishy wetness seeping into your shoes. You flick on the lights, and your heart plummets into your stomach. The place is flooded. A pipe burst over the weekend. Your brand new carpeting is a soggy, ruined mess. The drywall is dark and swollen. Your inventory, stacked neatly in the back room, is now a pile of waterlogged trash. The server rack that runs your entire operation is sitting in 2 inches of standing water, completely fried. The business you have poured your blood, sweat, and savings into is quite literally underwater. This isn't some rare freak accident you see in a movie. This is one of the single most common and financially devastating disasters that can strike a commercial property in the United States. Water damage and freezing pipes consistently rank among the top causes of commercial property loss, with the average insurance claim rocketing past $50,000. And let me be crystal clear. That is just the average. These incidents routinely spiral into the 6-figure, even 7-figure range. But the insurance payout, if you can even get it, doesn't cover the real killer. The true cost is the downtime, the days, weeks, or even months your doors are closed. The lost revenue, the salaried employees you still have to pay, the customers who go to your competitor and never come back, the damage to your reputation. A plumbing catastrophe isn't just a mess to clean up. It's an existential threat that can bankrupt a healthy business. But what if I told you that the vast majority of these so-called accidents are not accidents at all? They aren't random. They aren't unpredictable. In fact, they are almost always the result of small, overlooked issues that grew silently over time. They are ticking time bombs. And a plumbing system gives you warnings. It whispers before it screams. And over the course of this guide, I am going to teach you how to hear those whispers. I'm going to give you the exact playbook that the world's most successful property managers and savviest business owners use to defuse these time bombs and stop catastrophic plumbing failures before they ever have a chance to start. We are going to wage a war against the 3 silent killers of commercial plumbing systems: neglect, ignorance, and pressure. These aren't just leaky faucets or clogged toilets. These are the root causes, the systemic threats that are, at this very moment, working to undermine buildings all across the country. And chances are they're at work in yours too. Let's start with the first and most common killer: neglect. Commercial plumbing is the ultimate out-of-sight, out-of-mind system. It lives behind your walls, above your ceilings, and beneath your floors. You can't see it, so you don't think about it. You only react when something goes horribly wrong, when the water turns brown or the toilet backs up into the lobby. But every single major plumbing disaster is preceded by a series of small, ignored warning signs. That drain in the break room that's been getting a little slower every month? That's not just an annoyance. It's a symptom of a significant blockage forming deep within your lines. A blockage that could cause a system-wide backup. That tiny patch of moisture you saw on the ceiling tile a few weeks ago that you just ignored? That's the opening act for a catastrophic pipe failure that could flood an entire floor. Neglect is treating your plumbing like a magic box that should just work forever without any attention. It's the single biggest gamble a business owner can make. And the house always wins. The second silent killer is ignorance. And I don't mean that in a judgmental way. I mean a simple lack of specific knowledge. Most business owners mistakenly believe that commercial plumbing is just a bigger, tougher version of the plumbing in their house. This could not be more wrong. It's like comparing a go-kart to a freight train. They both have wheels, but they are fundamentally different machines operating under entirely different principles. Your commercial property has systems that your home could never dream of. High-pressure water mains, complex multi-unit water heaters, grease traps and interceptors mandated by law, backflow prevention devices that protect the municipal water supply, and intricate drainage systems designed to handle hundreds or even thousands of gallons of use per day. Using residential-grade solutions, or hiring a plumber who primarily works on houses, to To solve a commercial-grade problem is a recipe for absolute disaster. It's like asking a family doctor to perform brain surgery. Understanding the unique demands and components of your commercial system is not optional. It's the foundation of preventing its failure. And that brings us to the third silent killer: pressure. I mean this both literally and figuratively. First, the literal pressure. The water entering your building from the city main is often at an extremely high pressure, far too high for your internal pipes and fixtures to handle safely. This pressure can put immense, constant strain on every single pipe, joint, and valve in your building, dramatically shortening their lifespan and leading to sudden violent bursts. But there's also the figurative pressure, the sheer demand you place on the system. A restaurant's kitchen during the dinner rush, a laundromat on a Saturday, a gymnasium's locker room after a game, an apartment complex during the morning shower rush. These scenarios put a level of stress on a plumbing system that residential pipes could never withstand. If your building's use has changed over time, say an old office space was converted into a busy cafe, but the plumbing was never upgraded to match the new, higher demand, you are running on borrowed time. The system simply wasn't designed for that level of pressure, and eventually it will fail. So, how do we fight back against neglect, ignorance, and pressure? We stop reacting and start preventing. We stop hoping for the best and start preparing for the worst. We don't wait for the flood to start building an ark. And that's exactly what this guide is. It is your blueprint for building a fortress around your business's most vital and most vulnerable internal organ. Throughout this series, we're going to give you simple, actionable strategies that you can implement immediately. We will show you how to create a bulletproof preventative maintenance schedule that runs on autopilot, saving you thousands in emergency repairs. We'll teach you how to read the secret story your water bill is telling you every single month, a story that can reveal hidden leaks long before you ever see a drop of water. We will break down the 5 subtle warning signs of an impending pipe burst, how to properly manage your building's grease trap to avoid a 5-figure fine from the city, and why the specific type of water heater you have could be silently corroding your entire plumbing network from the inside out. This is about taking control. It's about shifting your mindset from a panicked victim of circumstance to a prepared, proactive owner who protects their investment. And that journey, that fundamental shift, begins with understanding the single most important and yet most commonly ignored device in your entire building. It's not a fancy faucet or a high-tech toilet. It's a small, unassuming valve that is the gatekeeper for every drop of water that enters your property. It controls the lifeblood of your plumbing system, and when it's not working correctly, it unleashes a destructive force that will tear your pipes apart. We're talking about your main water pressure and the critical device that tames it, the pressure-reducing valve. Most business owners don't even know where theirs is, let alone how to check it. Ignoring it is like letting a total stranger tinker with the engine of your car while you're driving 80 miles an hour down the freeway. So today, right now, we're going to pop the hood. And that hood covers one of the most critical, yet criminally overlooked, pieces of equipment in your entire building: the backflow prevention assembly. Think of it as the ultimate bouncer at the VIP entrance to your property's water supply. It lets the clean, pressurized water from the city main come into the party, but it has one non-negotiable rule. Once you're in, you can never, ever go back out. It's a one-way street, a check valve with an IQ and a badge. Its sole purpose is to protect the public water supply, your neighbors, the businesses next door, the entire community, from you. That sounds harsh, but it's the truth. The moment that clean city water passes through your meter and enters your building, it's considered used. It flows through your pipes, your cooling towers, your boilers, your sinks, your toilets. It comes into contact with all sorts of potential contaminants: cleaning chemicals, industrial waste, human waste, fertilizers from your irrigation system, even the soap and grease in a restaurant kitchen. This used water is now a potential hazard. And the backflow preventer is the legal and physical line in the sand that ensures your hazardous water never, ever mixes with the public's clean drinking water. This contamination happens in 2 main ways, and they are the twin villains of every municipal water authority. The first is called back siphonage. This is the drinking straw effect. Imagine a fire down the street from your building. The fire department hooks up to a hydrant and opens the valve, drawing a massive amount of water at an incredible rate. This causes a sudden, dramatic pressure drop in the city water main. Or maybe a water main breaks 2 blocks away, creating the same effect. Suddenly, the high pressure that normally pushes water into your building is gone. In its place is a vacuum. Your building's plumbing system, full of water, now has higher pressure than the empty city main. And just like sucking on a straw, the city main begins to pull or siphon the water from your building backwards out into the public supply. Let's make this real. Picture a janitor's closet in a medical clinic. A custodian is filling a mop bucket. He hooks a hose to the faucet, drops the end of the hose into the bucket, and turns on the water. The bucket is full of dirty water and a potent, hospital-grade disinfectant. He gets a call and walks away, leaving the hose submerged. At that exact moment, a construction crew hits a water main down the street. The pressure drops. A vacuum is created. The plumbing in that clinic becomes a giant straw, and that toxic chemical cocktail in the mop bucket gets sucked backwards, up the hose past the faucet, and straight into the building's water lines. A few minutes later, a nurse goes to the break room to get a glass of water for a patient. Without a functioning backflow preventer, that water is now poison. And worse, that poison could be siphoned all the way back into the city main, threatening every home and business connected to it. The second villain is back pressure. This is the overinflated balloon effect. This happens when your building's internal water system creates a pressure that is higher than the city's water pressure. This is common in buildings with pressurized systems like boilers, high-pressure pumps for a car wash, or even just a tall building where the sheer weight of the water in the pipes creates significant pressure at the bottom. If your internal pressure exceeds the city's pressure, it will literally force your used, potentially contaminated water backwards through the meter and into the public supply. Think about a manufacturing plant that uses water in its processes, water that gets mixed with solvents and chemicals. That water is held in a pressurized tank. If that system malfunctions or is simply designed improperly, and it creates a pressure of say 80 psi while the city main outside is only at 60 psi, the law of physics takes over. The higher pressure wins. The contaminated water from the plant will be forced out of the building, pushing against the flow of clean city water and contaminating the main line. This is why facilities with boilers, irrigation systems, or fire suppression systems are under such intense scrutiny. They are creating internal pressures that pose a constant backpressure threat. These aren't just hypotheticals. These are the scenarios that keep water department officials up at night. In one famous case, a university's chemistry lab was improperly connected to the water system. During a back-siphonage event, dangerous chemicals were pulled from a lab experiment back into the university's drinking water system, sending several people to the hospital. In another, a funeral home's embalming equipment was found to be directly cross-connected with the potable water lines. A backflow event in that scenario could introduce formaldehyde and other biohazards into the public water supply. A true public health nightmare. This is why the stakes are so astronomically high. A failed backflow preventer isn't a simple leak. It's not a clogged drain. It is a gateway to catastrophe. We're talking about widespread illness, chemical poisoning, and in the worst cases, death. And from a business owner's perspective, it's a legal and financial apocalypse. If your facility is identified as the source of a contamination event, you are facing crippling lawsuits from everyone affected. You're facing massive fines from the EPA and the local health department. Your business will be shut down indefinitely. The media will crucify you. Your brand and reputation, which you spent years building, will be destroyed overnight. The city isn't responsible for preventing contamination from your building. You are. Legally, ethically, and financially, your property is a potential contamination source, and you are required by law to contain that risk. That single mechanical device, the backflow preventer, is the only thing standing between your business operations and the health of your entire community. It's a silent, tireless guardian working 24/7. But like any guardian, it can get old, can get tired. Its parts can wear out, its seals can crack, and debris can jam it open. A backflow preventer that hasn't been tested is no better than having no backflow preventer at all. It's a placebo. It gives you a false sense of security while leaving your business and your entire community completely exposed. The terrifying part is that a huge percentage of these devices fail their annual inspection. They sit there year after year looking perfectly fine on the outside while internally they are a ticking time bomb. So, the million-dollar question is, where is this critical piece of hardware in your building? What does it even look like? And more importantly, how can you tell if it's working, or if it's just waiting for the right pressure drop to unleash a disaster? Finding it is the first critical step, and in the next part of this guide we're going on a hunt. I'll show you exactly where to look, what to look for, and how to identify the specific type of guardian protecting your building. Our hunt begins not in the wild, but in the concrete and steel heart of your building. Every commercial property, from a tiny coffee shop to a sprawling warehouse, has a single point of control for its water supply. This isn't just a piece of plumbing. It's the master switch, the emergency brake, the one valve that can mean the difference between a small leak and a catastrophic, business-ending flood. Knowing its location is as fundamental as knowing where the fire exits are. In a crisis, there is no time to search. There is only time to act. So, where do we look for this hidden guardian? Let's start with the most common layers. Your first stop on this expedition should be the building's lowest level. Head to the basement, the cellar, or the crawl space. Water, by nature, enters a building low and fights gravity to get to the upper floors. You'll want to walk the perimeter of the foundation, specifically the wall that faces the street. This is where the city's water main connects to your property. Look for a large pipe, typically 3/4 of an inch to several inches in diameter, emerging from the concrete floor or wall. Follow that pipe. Very close to where it enters, you will almost certainly find two things: the building's water meter, and right beside it, the main shutoff valve. It's often the very first valve on the line after it enters your domain. Now, if you're in a more modern or larger building, you might not have a traditional basement. Instead, you'll be looking for a dedicated mechanical or utility room. This is the nerve center of the building's operations. It's where you'll find the boiler, the main electrical panels, and the fire suppression system controls. It's a jungle of pipes and conduits, but don't be intimidated. Apply the same logic. Look for the water meter. It's your compass in this room. It's a clunky, official-looking device with a dial or a digital readout. The main shutoff valve will be its next-door neighbor, usually on the street side of the meter, meaning the water flows from the street through the valve, then through the meter. This ensures that a plumber can shut off the water to replace the meter itself if needed. But what if you can't find it inside? Or what if the inside valve fails? Every building has a second line of defense, a sort of master guardian that lives outside the castle walls. This is commonly called a curb stop or a street valve. You've walked over hundreds of them without a second thought. Look on the sidewalk or in the grassy area between the sidewalk and the street. You're searching for a small, round, or rectangular metal lid, usually about 4 to 6 inches across, often marked with the word water. Underneath that cover is a long, vertical pipe leading down to the valve on the main service line, sometimes several feet underground. Now, this is a critical distinction. This valve is often the city's property, and turning it usually requires a special long-handled key called a curb key. While you shouldn't operate this valve for routine maintenance, knowing its location is your ultimate ace in the hole. If a pipe bursts inside and your internal shutoff valve breaks or seizes, the fire department or an emergency plumber will go straight for this curb stop to kill the flow and save your building. For those of you managing very large properties, think industrial parks, apartment complexes, or university campuses, your guardian might be in an even more secluded spot: an underground water vault. These are essentially small concrete manholes, sometimes hidden under a heavy cast iron lid. Inside, you'll find a much larger configuration of pipes, meters, and valves that control the water for the entire site. Accessing these can be dangerous and is almost always a job for a professional, but as a building manager, you absolutely must know where this vault is located and have a map of the systems it controls. If all else fails, there is one ancient map that holds the secret: the building's blueprints. Somewhere in a dusty office or a city records archive are the original architectural and plumbing diagrams for your property. These prints will show the exact location where the water service enters the building, and will often have a symbol indicating the main shutoff valve. Finding these blueprints can feel like a treasure hunt in itself, but they are the definitive source of truth. Okay, so you've navigated the basement, you've explored the mechanical room, and you've pinpointed the likely location. You're standing in front of a maze of pipes. How do you identify the one true guardian from all the imposters? Simpler than you think. First, follow the size. The main water line will be the largest diameter water pipe coming into the building. Other pipes will branch off from it, but they will all be smaller. Trace that main artery back to its source. Second, use the water meter as your landmark. As we discussed, the valve will be right next to it. It's the gatekeeper standing guard right at the entrance. Now for the most important part of our hunt. You've found the valve, but what kind of guardian is it? Knowing its type is crucial, because each one operates differently and has its own unique strengths and weaknesses. There are 3 primary types you're likely to encounter. First, there's the old soldier, the most traditional of the guardians, the gate valve. This valve is easily identified by its handle, a round, multi-spoked wheel, like a miniature ship's helm. When you turn this handle, it slowly raises or lowers a solid metal gate inside the valve body to block the flow of water. Think of it like a guillotine for your water supply. The key thing to remember about gate valves is that they require multiple, sometimes 10 to 15, full rotations to go from fully open to fully closed. Their weakness? Age and neglect. If a gate valve isn't operated for years, mineral deposits can build up on the gate and its seat, or the stem can corrode. When you finally need it in an emergency, you might find it seized solid. Or worse, you apply too much force, the stem snaps, and now you have a permanently open valve and an unstoppable flood. The old soldier, if not respected and maintained, can fail you in the final battle. Next, we have the modern sentinel, the ball valve. This is the guardian you want on your side. It doesn't have a wheel. It has a single straight lever handle. Its operation is brilliantly simple. Inside the valve is a metal ball with a hole drilled through the center. When the lever is parallel to the pipe, the hole is aligned and water flows freely. To shut it off, you give the lever a simple quarter turn, just 90 degrees. This rotates the ball so the solid side blocks the pipe, stopping the water instantly. It's fast, it's reliable, and its handle gives you an immediate visual confirmation of its status. Parallel is open, perpendicular is closed. There's no ambiguity. If you have a ball valve as your main shutoff, you are in a much better position. They are far less likely to seize up and provide a clear, positive shutoff every time. Finally, there's a clever specialist, a guardian with an extra trick up its sleeve, the stop and waste valve. Visually, it often looks like a standard gate valve with a wheel handle, but it has one small, distinguishing feature: a little metal cap or thumb screw on the side of the valve body. This isn't just a valve, it's a drainage system. When you turn it off, it not only stops the water coming from the street, but that little cap allows you to open a small port that drains all the water remaining in the pipes inside your building. This is an absolutely critical feature in colder climates. It allows you to completely empty the system for the winter, preventing pipes from freezing, expanding, and bursting, which, as we know, is one of the most destructive plumbing disasters of all. So your mission is now clear. You need to go on this hunt. Find your main water shutoff. Is it in the basement? Is it in a utility closet? Then identify it. Is it the old soldier, the gate valve? The modern sentinel, the ball valve? Or the clever specialist, the stop and waste? Knowing this information is the foundation of your emergency preparedness plan. But just finding your guardian isn't enough. Seeing it is one thing. Knowing it will answer your call is another entirely. That old gate valve covered in dust and cobwebs, will even turn? Or will it snap the moment you put pressure on it? A guardian that is frozen in place, a sentinel that has fallen asleep at its post, is no guardian at all. It's just a liability waiting to betray you. And that brings us to the most crucial, hands-on part of our guide. We're not just going to look, we're going to act. It's time to test your valve, to gently and safely wake it from its slumber, and ensure it's ready for duty. In the next part, I'll walk you through the precise step-by-step process of exercising your main valve. A simple maintenance task that can save you tens of thousands of dollars and prevent a catastrophic failure when you need it most. So let's get right into it. The process of exercising your main water valve isn't just a good idea. It's one of the highest leverage, lowest cost preventative measures you can take. Think of it like this. Your building's main water shutoff is the emergency brake for your entire plumbing system. You might go years without needing it, but when you do, it absolutely positively has to work on the first try without hesitation. If it fails, you don't get a second chance. First, let's understand the enemy. What are we actually fighting against here? It's a silent, creeping process called mineral deposition and corrosion. Your water, even city-treated water, is full of microscopic minerals, calcium, magnesium, iron. Over time, these minerals settle inside the valve body, acting like a slow-motion superglue. They build up on the valve's gate or ball, on the threads of the stem, and in every tiny crevice. At the same time, oxidation or rust can begin to form, fusing metal parts together. The rubber or composite seals inside can also become hard and brittle from lack of movement, losing their flexibility. What you end up with is a valve that is literally cemented in the open position. It's not just stuck, it's seized. When you try to turn it in an emergency, one of two things usually happens. One, it simply won't move no matter how much force you apply. Or two, and this is the truly catastrophic outcome, the force you apply to the handle is too much for the corroded valve stem to handle. The stem, which is the metal rod connecting the handle to the internal gate or ball, snaps. you'll feel a sickening pop. The handle will spin freely in your hand, and you will have just turned a manageable leak into an unstoppable full-pressure flood with absolutely no way to shut it off from inside your building. Your only hope is a frantic, expensive emergency call to the city to shut the water off at the street, a process that can take hours during which water is destroying your property. This is the disaster we are preventing with a simple 5-minute procedure we call exercising the valve. Just like a human joint needs movement to avoid getting stiff, a valve needs to be operated periodically to stay functional. This process breaks up the light mineral deposits before they can harden into concrete. It clears away any early-stage corrosion, and it keeps the seals pliable. So how do you do it? Let's walk through the exact steps. Step 1 is preparation and identification. First, find your main water shutoff valve. It's typically located where the water main enters your building, in a basement, a utility closet, or a mechanical room. It will be on the largest pipe coming in from the outside. You also need the right tool. For a ball valve, which has a simple lever handle, you won't need a special tool. But for a large gate valve, which usually has a wheel-like handle or sometimes just a nut on top, you may need a dedicated valve wrench or a large adjustable wrench. Have it ready and stored right next to the valve. There is no time to hunt for tools during a flood. Before you touch anything, confirm which direction is off. The phrase righty-tighty, lefty-loosey almost always applies. Turning the handle clockwise closes the valve and shuts off the water. Counterclockwise opens it. For a ball valve with a lever, the rule is simple. When the handle is parallel to the pipe, it's open. When it's perpendicular to the pipe, it's closed. Take a moment to verify this. You might even want to put a small, clear label or tag on the pipe indicating the closed direction. Step 2 is the actual exercise. Now this is crucial. We are not trying to rip the handle off. This is about firm, steady pressure. Grip the handle or your wrench and begin to turn it slowly in the clockwise or close direction. You will likely feel some initial resistance. This is normal. It's the stiction we talked about, the initial bond of the minerals and corrosion. Apply smooth, consistent force. You should feel a small pop or break as the valve begins to move. This is a good sign. If it doesn't move with a reasonable amount of force, stop. I repeat, stop. Do not put a 3-foot cheater bar on the wrench and try to be a hero. A valve that's completely frozen requires a professional plumber who can use specialized techniques to free it or, more likely, replace it in a controlled manner. Forcing it is how you snap the stem. Assuming it moves, continue turning it clockwise slowly and steadily, all the way until it stops. Don't crank it down hard at the end. Just turn until it is fully seated and closed. You've now shut off the water to your entire building. This is a great time to have someone go to a nearby faucet and confirm that the water is indeed off. This verifies that the valve is seating properly and actually stopping the flow. Step 3 is reversing the process. Now, turn the handle counterclockwise to open it back up. Again, do this slowly. You're scraping away those mineral deposits as you go. Turn it all the way until it stops in the fully open position. Now, here is a critical pro tip specifically for gate valves, the ones with the wheel handles. Once it's fully open, turn it back in the clockwise, closing direction by about 1/4 of a turn. Why? Gate valves, if left in the 100% fully open position, can actually seize there, with the top of the gate wedging itself against the top of the valve body, or what's called the bonnet. That 1/4 turn back gives it just enough play to prevent this from happening, without restricting water flow in any meaningful way. For ball valves, this step isn't necessary. Fully open is fine. Step 4 is documentation. This simple task is useless if it's forgotten. Get a physical tag like a service tag you can buy at any hardware store, and attach it to the valve. With a permanent marker, write main valve exercised and the date. Then go to your digital calendar, your Google Calendar, your Outlook, your building maintenance software, and set a recurring reminder. How often? For most commercial buildings, doing this every 6 months is a great schedule. For facilities with known hard water, you might want to do it quarterly. This simple calendar event turns a one-time thought into a permanent, institutionalized process that protects your building long-term. Now, what if you notice a small drip from around the valve stem when you're turning it? Don't panic. This is very common. Around the stem under the handle, there's something called a packing nut. Its job is to compress a flexible material called packing around the stem to create a seal. Over time, this packing can loosen. If you see a small drip, take your wrench and gently tighten that packing nut. Again, just a 1/4 turn or so clockwise. In most cases, this will stop the drip. If it doesn't, that's a sign that the packing needs to be replaced, which is a simple and inexpensive job for a plumber, but it's something you need to address. Let me tell you a quick story that perfectly illustrates the value of this. I knew two facility managers for two nearly identical office buildings. Manager, let's call him Dave, was meticulous. Every 6 months he'd go down to the basement, spend 5 minutes exercising his main valve, and log it. Manager B, let's call him Tom, was always too busy for that kind of small stuff. One winter, a freak cold snap caused a fire sprinkler line to burst in both buildings over a weekend. Dave got the alert on his phone, drove to the site, calmly walked to his main valve, and shut the water off in under a minute. The damage was limited to some wet carpet. Tom got the same alert. He rushed to his building, found the main valve, and put a wrench on it. It was frozen solid. He heaved and then snap. The stem broke. He stood there, helpless, as thousands of gallons of water poured into the building for 2 hours until the city could finally get a crew out to shut it off at the street. Dave's company paid a few thousand for carpet cleaning. Tom's company faced over $100,000 in water damage, equipment replacement, and business interruption costs. Tom lost his job. The only difference? A 5-minute task done twice a year. That is the power you have. By mastering this one simple procedure, you're not just turning a valve, you're taking control of your facility's destiny. You're turning a potential 6-figure disaster into a minor inconvenience. Now that we've secured the main artery of your building's water supply, we need to talk about its immune system. There's another critical device, mandated by law in every commercial building, that sits silently, waiting to either do its job or fail spectacularly. It's your last line of defense, protecting not just your building, but the entire city's drinking water from contamination. I'm talking about your backflow preventer. And understanding how it works, and more importantly, how it fails, is the next critical step in our journey to making your building disaster-proof. It's a device that sits quietly, often in a forgotten corner of a mechanical room or in a box out by the street, doing a job so critical, yet so invisible, that most people don't even know it exists. But its failure can be catastrophic. Not just for your building, but for every home, every school, every hospital connected to the same water main. Imagine this scenario. It's a hot Tuesday in July. A few blocks away from your building, a construction crew accidentally strikes a major water main. Water erupts into the street, and the city's water pressure plummets. It's a massive drop, creating a powerful vacuum throughout the local water lines. It's the same principle as drinking from a straw. When you suck on the straw, you lower the pressure inside it, and the higher atmospheric pressure outside pushes the liquid up. Now, imagine the entire city water system is the straw, and that sudden water main break is a giant, invisible mouth sucking on the end of it. This is called back siphonage. At the same time, inside your building, a janitor has a hose connected to a utility sink faucet, the end of it submerged in a bucket of dirty water filled with potent industrial-strength floor cleaner. In another part of the building, the HVAC system's boiler is full of water treated with anti-corrosion chemicals. Chemicals you would never, ever want to drink. In a normal situation, the high pressure from the city water main keeps all of this contained within your building's plumbing. But right now the pressure isn't high. It's a powerful vacuum. And that vacuum is pulling, sucking everything it can back into the city pipes. The dirty, chemical-laden water from the janitor's bucket, the treated water from the boiler, it's all being drawn backwards, out of your building and into the public water supply, destined for the faucets of the businesses and homes downstream. This isn't a Hollywood fantasy. This is a very real and very dangerous phenomenon called backflow. It's the unwanted reversal of water flow, and it's one of the most serious public health threats in the world of plumbing. And it doesn't just happen from back siphonage. There's another, equally dangerous type, back pressure. This occurs when the pressure inside your building's plumbing system becomes greater than the pressure in the city's supply line. This can happen if you have a booster pump, a high-rise building where the sheer weight of the water creates pressure, or a pressurized system like a boiler. In this case, your system can literally overpower the cities and push contaminated water back into the main. This is why the backflow preventer exists. It is the non-negotiable line of defense, a mechanical guardian angel standing watch over the connection point between your building and the public water supply. Its only job is to be a one-way gate, allowing city water to flow in, but physically stopping anything from flowing out. Now, not all backflow preventers are created equal. The type you need depends entirely on the level of hazard your building presents to the water supply. Think of it like a security system. You wouldn't use a simple screen door to protect a bank vault. For low-hazard situations where the worst thing that could flow back is just stagnant or discolored water, like from a fire sprinkler system, you might have what's called a double check valve assembly or a DCVA. It's essentially two independent check valves in a row. The idea is that if one fails, the other one will still hold. It's good, but it's not foolproof. For something like an irrigation system where you could be siphoning fertilizer or pesticides from the lawn, you'd need a pressure vacuum breaker or a PVB. These are designed to protect against back siphonage and are a common sight in commercial landscaping. But for high-hazard situations, and this includes any place where the water could come into contact with chemicals, medical waste, industrial fluids, or human waste, you need the gold standard. You need the king of backflow prevention, the Reduced Pressure Zone Assembly or RPZ. If you have a commercial kitchen, a laboratory, a car wash, a hospital, or a manufacturing facility, you almost certainly have one of these. And you need to understand it. An RPZ is a marvel of simple, life-saving engineering. Like the DCVA, it has two independent check valves, but it has a critical third component, a differential pressure relief valve located in a chamber between them, called the zone. Here's how it works. In normal operation, water flows through the first check valve into the zone, and then through the second check valve into your building. The device is designed so that the pressure in the middle zone is always at least 2 pounds per square inch lower than the incoming supply pressure. It's a reduced pressure zone. If the second check valve fails and starts to leak, allowing higher pressure water from your building to push backwards, that pressure in the zone will start to rise. The moment it gets too close to the supply pressure, that relief valve in the bottom opens up and dumps the water out onto the floor. It's a built-in tattletale. It creates a mess for sure, but that mess is infinitely better than allowing a potential contaminant to get one step closer to the public water supply. Even better, if a back siphonage event happens and the pressure from the city main drops, the first check valve closes. As the pressure drops, that relief valve opens again, creating an air gap and making it physically impossible for anything to be siphoned backwards. It's a brilliant, fail-safe design. But here's the crucial point, the part that so many building owners miss. It is a mechanical device. And mechanical devices fail. The springs inside can weaken. The rubber seals and O-rings can dry out, crack, or become brittle. And the most common cause of failure is microscopic debris. A tiny grain of sand, a fleck of rust from an old pipe, or a piece of sediment can get lodged in the seat of a check valve, holding it open just a fraction of a millimeter. That's all it takes. Your impenetrable one-way gate is now a two-way street. Your fail-safe is no longer safe. This is why, in virtually every municipality in the United States, annual testing of backflow preventers isn't just a good idea. It's the law. This is not a suggestion. It's a mandate from your water utility, enforced with serious penalties. A certified backflow tester doesn't just look at the device. They connect a specialized differential pressure gauge kit with hoses to test ports on the assembly. They meticulously follow a set procedure, manipulating the shutoff valves and measuring the pressure readings to simulate both back pressure and back siphonage conditions. They are verifying with scientific certainty that both check valves are holding a watertight seal, and that the relief valve on an RPZ opens at the precise, correct pressure differential. If your device fails the test, it must be repaired or replaced immediately, and then retested. If you ignore the notice from your water department to get your annual test, the consequences are severe. First come the fines, which can be substantial. If you continue to ignore it, they will come and shut off your water. They will physically disconnect your building from the city supply until you comply. Why are they so strict? Because the stakes are that high. They are protecting the entire community from one building's potential negligence. And the legal liability for you, the building owner, is staggering. If a contamination event occurs and your building is identified as the source because of a failed, untested backflow preventer, you are facing a legal and financial nightmare that could bankrupt your business and follow you for the rest of your life. All for skipping a test that typically costs a few $100s. So your action item is this: find out what kind of backflow preventer you have, where it is, and when it was last tested. Look for a tag attached to the device. It should have the date of the last test and the name of the certified company that performed it. If it's been more than a year, or if there's no tag at all, you need to get it tested immediately. Don't just call any plumber. You need to find a technician who is specifically certified in backflow testing and repair. Your local water utility can provide a list of approved testers. This isn't about plumbing maintenance. It's about public health and risk management. That unassuming brass device is the silent guardian standing between a clean, safe water supply for thousands of people and a potential public health disaster originating right inside your walls. It's the one piece of equipment where out of sight, out of mind can lead to truly catastrophic consequences. Now that we've secured the water coming into your building, we need to address the single biggest cause of plumbing emergencies: the water going out. Because what goes down your drains has the power to bring your entire operation to a screeching, disgusting, and incredibly expensive halt. I'm talking about the number one enemy of commercial sewer lines: grease. And the story of how a single kitchen can create a 1,000-foot-long monster lurking beneath the streets is where we're going next. Starts innocently enough. A chef in a busy restaurant kitchen finishes searing a batch of steaks. He tilts the hot, sizzling pan over the floor sink and blasts it with hot water from the sprayer. The shimmering liquid fat vanishes down the drain. Problem solved, right? Wrong. He's just fed the monster. In another part of the city, a dishwasher scrapes leftover buttery pasta sauce into a sink equipped with a garbage disposal, grinding it up and sending it on its way with a torrent of scalding water. He's just helped the monster grow. This scene repeats itself thousands of times a day, in every restaurant, hotel, hospital, and school cafeteria. And every single time, they are contributing to the creation of a subterranean horror. The monster has a name, an acronym known to every municipal water authority and every frustrated plumber: FOG. Fats, oils, and grease. It's the byproduct of our favorite foods. The bacon grease from the breakfast rush, the deep fryer oil from lunch, the creamy salad dressings and rich sauces from dinner service. When it's hot, it's a liquid seemingly as harmless as water. And this is the great deception. The hot water used to wash it down the drain gives a false sense of security. But the moment that greasy water hits the cold, dark pipes buried underground, a transformation begins. Think of it like candle wax. When it's hot, it's liquid. When it cools, it becomes a solid. The exact same thing happens with FOG. As it travels down your drain lines, it cools rapidly and solidifies, clinging to the inside of the pipes. It's the plumbing equivalent of cholesterol building up in an artery. First, it's just a thin, sticky film. But this film is the perfect trap. It acts like flypaper for everything else going down the drain: food particles, coffee grounds, hair, and most notoriously, so-called flushable wipes that don't actually break down. These items get caught in the sticky grease, creating a small but growing clump. Over time, this process repeats. Every new wave of hot, greasy water adds another layer. The clump grows larger, harder, and more dense. It's no longer just grease. It's a composite material, a foul agglomeration of waste bound together by solidified fats. This is the birth of a fatberg, and they can grow to truly terrifying proportions. In September of 2017, underneath the streets of Baltimore, Maryland, maintenance crews made a horrifying discovery. For weeks, they'd been trying to figure out why a major sewer main was backing up. When they finally sent a camera down into the darkness, they found the culprit. It was a fatberg of epic proportions, a congealed, concrete-like mass of grease, wet wipes, and human waste that was blocking nearly 85% of a 12-foot diameter pipe. This toxic iceberg was so massive and so dense that it caused a catastrophic failure in the system, forcing more than 1 million gallons of raw sewage to overflow into a local stream. Think about that. 1 million gallons of filth, all because of what went down the drain. The city had to bring in high-pressure water jets and industrial vacuum trucks to wage a week-long war against the monster, breaking it up piece by piece and sucking it out. Now you might be thinking, my little coffee shop or restaurant isn't going to create a city-blocking behemoth. And you're probably right. But the same exact process that created the Baltimore fatberg is happening inside your building's plumbing right now on a smaller scale. That slow drain in the kitchen? That's the artery starting to clog. That faint, foul odor you can't quite place? That's the smell of grease beginning to rot inside your pipes. And when that blockage finally becomes complete, it won't just be a slow drain. It will be a full-blown sewer backup, sending rancid, contaminated water bubbling up from your floor drains, shutting down your business, costing you thousands in emergency plumbing bills and lost revenue, and potentially earning you a hefty fine from the city. So how do you stop this monster before it's born? You install a bouncer at the door of your plumbing system. This bouncer is called a grease trap, or for larger applications, a grease interceptor. Its job is brilliantly simple. It's a box that your kitchen wastewater flows into before it enters the main sewer line. Inside the box, a series of baffles slows the water down, giving it time to cool. As it cools, the magic of physics takes over. The fats, oils, and grease are lighter than water, so they float to the top. The heavy food solids sink to the bottom, and the cleaner water in the middle is then allowed to flow out and into the city sewer. The bouncer has done its job, keeping the troublemakers out of the club. These traps come in two main flavors. For smaller operations like delis or coffee shops, you might have a small under-sink unit. For high-volume restaurants, hotels, or hospitals, you'll have a huge, concrete interceptor buried in the ground outside, often with a capacity of 1,000 gallons or more. But here is the single most important thing to understand. A grease trap is not a garbage disposal. It is not a magic grease eliminator. It is a holding tank. And if that tank isn't emptied regularly, it becomes completely useless. When a grease trap gets full, there's no more room for the grease to separate and collect. The new, hot, greasy water you pour down the drain just flows right in one side, stirs up the disgusting mess, and flows right out the other side, carrying all that fog with it directly into your sewer lines. You've essentially installed an expensive, foul-smelling box that does absolutely nothing. Your bouncer is asleep on the job. This is why regular, professional maintenance is not optional. It's mandatory. Depending on your business volume and the size of your trap, it needs to be pumped out by a licensed professional on a strict schedule, whether it's weekly, monthly, or quarterly. Failure to do so not only guarantees an eventual backup, but it can also lead to massive fines from municipal inspectors who check these systems. They don't mess around because your grease problem becomes their million-gallon sewage overflow problem. The war on grease isn't just fought with traps and pumps, though. Starts with your staff and your culture. The best defense is to prevent the grease from ever entering the drain in the first place. This requires training and constant reinforcement. First, scrape everything. Scrape plates, pots, and pans into the trash can before they ever touch water. Second, wipe them down. Use a paper towel to wipe off any residual grease before washing. Third, can the oil. Never ever pour used fryer oil down the drain. It should be collected in a rendering barrel for proper disposal or recycling. Install mesh screens on all your drains to catch solids. And post signs, lots of signs reminding your team of these rules. Because every drop of grease they keep out of the drain is a victory that saves you a fortune down the road. Managing grease is a non-negotiable part of running any commercial food service operation. It's a battle fought on two fronts, with the right equipment and maintenance, and with the right training and procedures. Get both right, and you'll starve the monster before it ever has a chance to grow. Get it wrong, and it's only a matter of time before it crawls back up your pipes. But grease isn't the only invisible enemy trying to destroy your plumbing from the inside out. There's another, far more insidious culprit that many business owners actively invite into their pipes, thinking it's a helpful solution. I'm talking about the liquid in the plastic bottle, the chemical drain cleaner. And the story of how this supposed quick fix can cause catastrophic, irreversible damage is a lesson you can't afford to miss. Starts with a promise. A simple, seductive promise whispered from the hardware store shelf. Clog gone in 15 minutes. Destroys hair and grease on contact. Feels like a magic wand. You have a slow drain in a tenant's bathroom or a backed-up sink in the employee break room. The pressure is on. You don't have time to call a plumber to wait to shut things down. So you grab the bottle. Feels heavy, substantial, powerful. You pour it down the drain and for a moment you feel like a hero. You've solved the problem. But what you can't see deep inside the dark, hidden arteries of your building is that you haven't solved a problem. You've just started a much, much bigger one. To understand why, you have to understand what's actually in that bottle. It's not magic. It's brutal, brute force chemistry. Most of these cleaners are either a powerful acid, like sulfuric acid, or a potent base, like sodium hydroxide, also known as lye. When these chemicals mix with water and the organic material in the clog, they trigger a powerful exothermic reaction. Exothermic is just a scientific way of saying it gets incredibly hot. We're not talking about hot tap water. We're talking about temperatures that can approach the boiling point of water, and sometimes well beyond. You're essentially creating a small, contained chemical volcano right inside your plumbing. Now think about what your pipes are made of. In most modern commercial buildings, you're looking at PVC or ABS plastic. These materials are durable, but they have a weakness: heat. When that chemical volcano erupts inside your PVC pipe, the plastic begins to soften. It loses its structural integrity. It can warp, sag, or create a belly in the pipe where water will pool from now on, creating a perfect spot for future clogs. The intense heat can also damage the solvent-welded joints, the glue that holds your whole drain system together. It can compromise the rubber gaskets and seals. You might clear that one clog, but you've just permanently weakened the pipe, creating a ticking time bomb for a future leak right in that very spot. And if you have an older building with cast iron or galvanized steel pipes, the story is even worse. These chemicals are unbelievably corrosive. They don't just dissolve the hair and grease, they dissolve the pipe itself. The acid literally eats away at the metal, stripping away layers of iron that have been there for decades. It accelerates rust, it creates pits, and it thins the pipe walls until they're paper thin. Every time you pour it down the drain, you're taking a little bit of the lifespan off your plumbing system. You're trading a $50 plumbing visit for a future 5-figure repiping project. But here's the absolute nightmare scenario, the one that keeps plumbers up at night. What happens when the chemical drain cleaner doesn't work? What if the clog is too dense, too far down the line? Now, you don't just have a clogged pipe. You have a clogged pipe filled with a gallon of highly toxic, flesh-melting chemicals, just sitting there. All of that heat, all of that corrosive power, is now concentrated on one single section of your pipe. It's no longer a quick flash of heat, it's a slow, relentless cook. It will warp, melt, and eat through that pipe with terrifying efficiency. And this is where the problem moves from infrastructure damage to a serious human safety issue. A maintenance person or a tenant, not knowing what's been done, might try to use a plunger. The pressure can cause that caustic chemical to erupt back out of the drain, causing severe burns to the face and eyes. Or you finally give in and call the professional. The plumber arrives, assuming it's a standard clog. They feed their metal snake, their auger, down the drain. The cable whips around in that pool of acid, and when they pull it back out, it's coated in it. It flings droplets onto their skin, their clothes, the tenant's floor. They can suffer horrific chemical burns, and their expensive equipment can be ruined. This is why many professional plumbers will flat out refuse to work on a line if they know chemical cleaners have been used, or they'll charge a significant hazard fee. By trying to save a few bucks, you've not only failed to fix the problem, you've made it exponentially more dangerous and expensive to solve. The damage doesn't stop at the pipe either. Let's say the chemical cleaner successfully weakens a joint just enough to create a slow, pinhole leak behind a wall. You don't see it. For weeks, maybe months, water seeps into the drywall, the insulation, the wooden studs. You've now got a hidden mold colony growing in your walls. The smell starts, tenants complain of respiratory issues, and suddenly that $5 bottle of drain cleaner has turned into a $20,000 project involving not just plumbers, but mold remediation specialists, drywall contractors, and painters, not to mention the cost of lost rent and business interruption. Now, I know what some of you are thinking. I've used it for years, and it's always worked fine for me. And you might be right. But using chemical drain cleaner is like playing Russian roulette with your building's infrastructure. The damage is cumulative. Each use is another little bit of wear, another microscopic bit of metal etched away, another slight warp in the plastic. You don't notice the damage happening, just like a smoker doesn't feel their lungs degrading with each cigarette. It all seems fine until one day it isn't. One day, a pipe that has been silently weakened for years finally gives way, and you have a flood. So what's the alternative? How do you handle clogs safely and effectively? The answer is to think like a plumber. First, go mechanical. A simple plunger is your best friend. For a sink, make sure to block the overflow drain with a wet rag to get a good seal and real pressure. For tougher clogs near the drain opening, a small hand crank snake or auger is an inexpensive tool that can physically break up or pull out the blockage without any harmful chemicals. But the real pro-level move, the one that prevents most clogs from ever happening in the first place, is to switch from chemical warfare to biology. I'm talking about enzymatic drain cleaners. These are not caustic acids or bases. They're a solution containing beneficial bacteria and enzymes. When you pour them down the drain, they don't burn through everything in their path. Instead, these microorganisms get to work eating and digesting the organic waste, the grease, the food particles, the soap scum, the hair. It's a slow process. You usually use them overnight. They won't clear a total blockage in 10 minutes. But they are completely safe for your pipes, safe for the environment, and safe for the people who use them. Using an enzymatic cleaner once a month in all your drains isn't a fix. It's maintenance. It's like changing the oil in your car. It keeps the whole system running smoothly and prevents the catastrophic failures from ever happening. So we've dismantled the myth of the quick chemical fix for a single clogged sink or floor drain. We've learned that the smart money is on safe, mechanical, and biological solutions that protect your investment. But what happens when the problem isn't just one drain? What happens when every toilet in the building starts gurgling, when drains on the ground floor start backing up simultaneously? That's the sign of a much bigger beast. The problem isn't in the small pipes anymore. It's in the main artery of your building's waste system. I'm talking about the main sewer line. And the number one enemy of that line, especially in any building with a kitchen, is a greasy, solidifying monster of our own creation. It's a problem so massive it has its own terrifying name, the fatberg. It's a disgusting rock-hard mass of congealed fats, oils and grease, what plumbers call a filth, all bound together by the things that should never have been flushed in the first place. I'm talking about wet wipes, paper towels, dental floss, cotton swabs, and all manner of other debris. It's not a simple clog. It's a subterranean monster. It grows slowly, insidiously, deep within the dark, forgotten arteries of the city's sewer system, or worse, in the main sewer line leading from your commercial property. Starts innocently enough. A little bit of warm grease from a dishwasher gets poured down a drain. As it travels down the pipe, it cools and solidifies, clinging to the rough interior of the sewer line. It's a tiny, insignificant layer. But then the next day another layer is added. And another. Soon this sticky residue acts like flypaper. A supposedly flushable wipe, which doesn't break down like toilet paper, gets snagged. Then a strand of dental floss wraps around it. More grease coats that. Slowly, methodically, this mass begins to grow. It's not just accumulating. It's chemically changing. This is where the true horror of the fatberg begins. It undergoes a process called saponification. That's a fancy word for soap making. The fats, the fatty acids in the FOG, react with the alkaline environment of the sewer system. Think of all the bleach, detergents, and other cleaning chemicals going down the drains, not to mention the calcium from the concrete pipes themselves. This reaction transforms the soft, greasy sludge into a hard, waxy, soap-like substance. It becomes a solid, immovable plug, sometimes as hard as concrete, fused to the inside of the pipe. You can't just pour a chemical drain cleaner on this thing and hope it goes away. You can't use a simple plumber's snake. Removing a mature fatberg requires high-pressure water jets that operate at thousands of psi, specialized cutting tools, and sometimes, it means literally excavating the street to cut out and replace an entire section of the city's sewer main. The fatberg that crippled London's sewer system in 2017 was over 800 feet long and weighed 130 tons, the same as 11 double-decker buses. And the cost to remove it? Millions. Now, why does this matter to you, the owner of a commercial building? Because your property, especially if it houses a restaurant, a cafeteria, a hotel kitchen, or any food service operation, is ground zero. You are the primary source of the fatberg's food. Every single day, commercial kitchens produce a staggering amount of fats, oils, and grease. Think about the deep fryers, the griddles, the rotisserie ovens, the wok stations. Think about the pots and pans being rinsed, the dishes being washed, the greasy floors being mopped. Every drop of that fog-laden water is a potential building block for disaster. And while a city-blocking monster is the worst-case scenario, the more immediate threat is a fatberg forming in your lateral line, the pipe that connects your building to the main city sewer. If that line gets blocked, there is nowhere for your building's wastewater to go. The result is a sewer backup, and not a clean water backup. We are talking about raw sewage backing up through your floor drains, into your kitchen, into your bathrooms, into your dining areas. It is an absolute business-ending catastrophe. It's a health department shutdown, a public relations nightmare, and a cleanup bill that can easily run into the tens, if not hundreds of thousands of dollars. So how do we fight this monster? How do we stop it before it's even born? The answer lies in a crucial, often misunderstood, and frequently neglected piece of equipment: the grease interceptor, more commonly known as the grease trap. A grease trap is the unsung hero of commercial plumbing. It is your building's first and most important line of defense against FOG. Its job is simple yet brilliant. It's essentially a holding tank that all the wastewater from your kitchen sinks and floor drains flows through before it enters the sewer line. The design allows the water to slow down and cool. As it cools, the magic of physics takes over. The FOG, being lighter than water, floats to the top. The solid food particles, being heavier, sink to the bottom. In the middle, a layer of relatively clear water is able to flow out of the trap and safely into the sewer system. The grease trap has, quite literally, intercepted the grease. But here is the critical point, the one that separates responsible business owners from those on a collision course with disaster. A grease trap is not a magic box. It is not a set-it-and-forget-it appliance. It is a filter, and just like any filter, it eventually gets full. And a full grease trap is not only useless, it's a ticking time bomb. When a grease trap is full, the separation process can no longer happen. The FOG has nowhere to go. So the incoming wastewater simply flows straight through the trap, carrying all of that grease and oil with it, and deposits it directly into your sewer lines, the very thing it was installed to prevent. Even worse, a neglected grease trap begins to rot. The decomposing food and grease create hydrogen sulfide gas, which produces an overpowering foul odor of rotten eggs that can permeate your entire establishment and drive customers away faster than a fire alarm. Preventing this is not complicated, but it requires diligence. It requires a proactive plan. First, you must know your trap and your local regulations. Municipalities across the country have strict codes regarding grease interceptors. They dictate the required size of your trap based on your kitchen's output. And most importantly, they mandate a maintenance schedule. Ignoring these codes can lead to massive fines. Second, and this is non-negotiable, you must have your grease trap professionally pumped on a regular basis. The industry standard is called the 1/4 rule. You should have the trap cleaned out when the combined layer of fog on top and solids on the bottom takes up 25% of the trap's volume. For a busy restaurant, this could mean a professional pumping service every month. For a smaller operation, it might be every 3 months. But it has to be done. This is not a task for an employee with a bucket. It requires a specialized vacuum truck and a licensed professional who will properly dispose of the waste. Third, and arguably the most important step, is staff training. The war on fog is won or lost in the day-to-day habits of your kitchen staff. You need to create a culture of fog awareness. This starts with the simple act of scraping. All plates, pots, and pans must be thoroughly scraped into the trash can before they touch water. Every bit of solid food and congealed grease you keep out of the sink is a victory. Install heavy-duty screens on every single drain, from the 3-compartment sink to the floor drains, and make it a closing duty to clean them every single night. And the cardinal rule: never ever pour used cooking oil down any drain. Not the sink, not the toilet, not the floor drain. That liquid gold in your deep fryer is a fatberg's favorite meal. It must be collected in a dedicated rendering bin to be picked up by a cooking oil recycling service. Many of these services will even pay you for your used oil. You can literally get paid to prevent a plumbing disaster. Finally, be wary of magic solutions. You will see products, often enzymes or harsh chemicals, that claim to dissolve grease in your pipes. Avoid them. Most of these products don't actually eliminate the grease. They simply break it down or emulsify it, allowing it to pass through your grease trap and re-solidify further down the line, out of sight and out of mind, where it can cause an even more expensive blockage in a less accessible location. The only true solution is physical removal. Get the grease out of your building. The cost of a regular pumping service, a few $100s every couple of months, can seem like just another expense on a long list. But it's not an expense. It is one of the most critical investments you can make in the health and longevity of your business. Because when you compare it to the cost of an emergency sewer line replacement, a business shutdown, health code fines, and the permanent damage to your reputation from a raw sewage backup, that maintenance bill becomes one of the best bargains you'll ever find. So we've fortified our defenses against the enemy we create inside our walls. But what about the threats that come from outside? The ones that silently invade our property from below ground, turning our own landscape against us? Because the next plumbing disaster we need to talk about doesn't start in the kitchen. It starts with a single tiny seed. That seed, planted decades ago, has a singular, relentless purpose: to seek water and nutrients. And on your commercial property, there is no greater source of both than your sewer line. It's a subterranean buffet, a constant, nutrient-rich stream flowing just a few feet below the surface. The tree doesn't know it's a pipe, doesn't care. To the tree, it's just a whisper of moisture, a promise of life. And so it begins. A single hair-like root tip, guided by an almost imperceptible vapor trail escaping from a tiny crack or a loose joint in your sewer pipe, starts its journey. It's not an aggressive assault. It's a patient, methodical exploration. This root tip, no thicker than a human hair, probes and presses. If it finds even the smallest imperfection, a hairline fracture in an old clay pipe, a deteriorating seal on a cast iron joint, it will exert a slow hydraulic pressure that is almost impossible to stop. Once inside, the root enters a paradise. It's warm, it's dark, and it's filled with everything a tree could ever want. And it does what any living thing does when it finds paradise. It thrives. It explodes into a fibrous mass, a dense network of tendrils that quickly fills the entire diameter of the pipe. But it doesn't stop there. As this internal root ball grows, it acts like a wedge, exerting immense, constant pressure from the inside out. The tiny crack becomes a fracture. The fracture becomes a break. The pipe itself begins to collapse under the strain. Up on the surface, you notice nothing at first. The beautiful, mature oak tree on your property is a selling point, a landmark that adds value and shade. But below, this silent saboteur is laying siege to your infrastructure. The first signs are subtle. A toilet in the back office that needs to be plunged more often. A faint gurgling sound from a floor drain after a busy lunch rush. You might call a handyman who snakes the line. It works for a little while. But you haven't solved the problem. You've just temporarily annoyed it. The roots grow back, thicker and more determined than before. Imagine a thriving downtown restaurant. Let's call it the Landmark Bistro. It's known for its historic charm, and the centerpiece of its outdoor patio is a magnificent, 70-year-old maple tree. It's on their logo, it's in their marketing materials. That tree is the Landmark Bistro. One day, the drains in the kitchen start running slow. They get them cleared. A month later, it's the guest restrooms. This time, a plumber uses a more powerful auger and pulls back a small clump of roots. He warns the owner, but business is booming, and the recommendation for a full camera inspection and hydrojetting seems expensive and excessive. A major renovation is planned for next year anyway. They'll deal with it then. This is the critical mistake. They treated the symptom, not the disease. The root mass, now pruned, grows back with a vengeance. It's a biological certainty. 3 months later, on the busiest Saturday night of the year, it happens. A complete blockage. Not a slow drain, but a full-on catastrophic backup. Wastewater begins seeping up from the floor drains in the kitchen. A foul, unsanitary flood that shuts down service instantly. The patio, filled with diners, has to be evacuated as the main sewer line outside begins to overflow. The emergency plumber arrives. There's no auger that can fix this. They run a camera down the line and show the owner the horrifying footage on a small screen. The pipe isn't just blocked, it has completely collapsed. The relentless pressure from the root system has crushed the old clay pipe like a soda can. The Landmark Bistro doesn't just close for the night. It closes for 3 weeks. They have to excavate their beautiful historic patio, destroying years of work. They have to cut down the iconic maple tree, the very symbol of their business, to access and replace the entire sewer line. The cost is astronomical, not just in the tens of thousands of dollars for the repair, but in the hundreds of thousands of dollars in lost revenue, ruined reputation, and the permanent loss of their brand centerpiece. This story, or a version of it, plays out on commercial properties across the country every single day. And it is almost entirely preventable. Preventing a root invasion isn't a one-time fix. It's a strategy of proactive defense. Your first and most powerful weapon is knowledge. You must have your sewer lines inspected with a camera, a process called a sewer scope, every 1 to 2 years, especially if your property has mature trees. This is non-negotiable. A sewer scope is the equivalent of sending a drone into enemy territory. A technician feeds a high-resolution camera down your main line, allowing you to see its exact condition in real time. You will see small root intrusions long before they become blockages. You will see cracks, offsets, and bellies in the pipe that are potential entry points. This inspection is your intelligence report, and it dictates your entire strategy. It's not an expense. It's an investment that can save you from a 6-figure catastrophe. If the inspection reveals early-stage root intrusion, your next step is a hydrojetting service. This isn't your standard drain snaking. A hydrojetter uses incredibly high-pressure water, up to 4,000 psi, to blast through obstructions. A specialized spinning nozzle scours the inside of the pipe, obliterating root masses and washing them away. It restores the pipe to its original diameter, and is the most effective way to clear an existing line without excavation. Think of it as pushing the reset button on your pipes. But clearing the roots is only half the battle. You have to manage the source. This is where strategic landscaping comes in. If you are developing a new property or renovating your landscape, be incredibly mindful of what you plant and where you plant it. Trees with aggressive water-seeking root systems, like willows, poplars, aspens, and silver maples, should never be planted within 50, even 100 feet of a main sewer line. Opt for slower-growing trees with less invasive root systems if you want them near the building. For existing trees, you can sometimes install a root barrier. This involves digging a deep trench and installing a physical barrier of plastic or metal to deflect roots down and away from your pipes. It's a significant undertaking, but far less significant than a full sewer line replacement. The material of your pipes also plays a huge role. If your property was built before the 1980s, you likely have pipes made of clay tile or cast iron. These materials are highly susceptible to root intrusion. Clay pipes are brittle and were laid in short sections, creating numerous joints that can fail over time. Cast iron rusts and corrodes, creating rough surfaces that snag waste and provide entry points for roots. If a camera inspection reveals that your old pipes are riddled with roots and cracks, the most resilient long-term solution is to replace them with modern materials like PVC or ABS plastic. These pipes are flexible, impervious to corrosion, and use solvent-welded, watertight joints, offering a nearly impenetrable defense against root invasion. A more modern, less invasive option is trenchless pipelining, where a new seamless pipe is essentially created inside your old one, sealing off all cracks and joints without major excavation. It's a capital expense, but it eliminates the threat permanently. Fighting tree roots is a battle against one of nature's most persistent forces. You cannot win with a single reactive skirmish. You win by understanding the enemy. You win with regular surveillance through camera inspections. You win with decisive, powerful countermeasures like hydrojetting. And you win by building long-term, impenetrable defenses through smart landscaping and modern infrastructure. The tree on your property can be your greatest asset or your most costly liability. The difference lies in whether you are managing just the building or the entire ecosystem it inhabits. And this idea of managing the unseen, of understanding the forces working against your property that are completely invisible to the naked eye, brings us to our final, and perhaps most insidious plumbing disaster. This one isn't caused by grease or foreign objects, or even the forces of nature. This disaster is caused by the very water your system is designed to carry, when it turns from a tool into a weapon of slow, silent destruction. We're talking about the chemistry of your water, the unseen elements within it that wage a constant, patient war against the inside of your pipes, fixtures, and appliances. It's a battle fought molecule by molecule, over months and years, completely hidden from view until the moment of catastrophic failure. Let's start with the most common saboteur, hard water. You've probably heard the term, but for a commercial building, it's more than just a nuisance that leaves spots on your dishes. Hard water is water with a high concentration of dissolved minerals, primarily calcium and magnesium. As this water flows through your system, and especially when it gets heated, these minerals precipitate out and form a rock-hard deposit called limescale. Think of it like cholesterol in an artery. Drop by drop, day by day, this scale builds up on the inside of your pipes, narrowing the passage. Your pumps have to work harder, your energy bills creep up, and water flow to your top floors diminishes. But the real danger is inside your boiler and water heater. The heating elements get coated in this layer of mineral stone. The unit now has to fight to heat the water through this insulator, causing it to overheat, drastically reducing its efficiency and lifespan. We're talking about a commercial water heater that should last 15 years, failing in 5. And in the worst-case scenario, this localized overheating can create a pressure buildup so extreme it can cause the tank to rupture with explosive force. All from minerals you can't even see. But the mineral attack is only one front in this war. The other is corrosion. This is the chemical decay of the metal itself. Your water's pH level plays a huge role here. If your water is too acidic, it becomes aggressive, actively eating away at copper and iron pipes from the inside out. You might notice the early signs as blue-green stains in sinks from copper pipes, or reddish-brown water from iron pipes. But the real damage is invisible. A pipe can look perfectly sound from the outside while its internal walls have been thinned to the consistency of foil. It's a ticking time bomb, waiting for a slight pressure surge to tear it open and release a torrent of water into your walls, ceilings, and operational spaces. And sometimes it's not even about the water's chemistry, but the metals themselves. When two different metals like copper and galvanized steel are plumbed together without a proper dielectric union, you create a battery. The water acts as the electrolyte, and a process called galvanic corrosion begins, where one metal literally sacrifices itself to the other, rapidly deteriorating at the connection point until it fails. Now let's add a third accomplice to this silent destruction: pressure. Your building's plumbing is designed to operate within a specific pressure range, typically between 50 and 80 psi. But municipal water pressure can often exceed this, sometimes spiking to over 100 or even 150 psi. When your system is subjected to this relentless, excessive force, it's like running your car's engine constantly in the red. Every single component is under immense stress. The seals in your faucets, the diaphragms in your toilets, the joints in your pipes, the flexible supply lines to your sinks. They all wear out exponentially faster. That faint dripping sound you hear is often the first cry for help. But the real disaster is the sudden blowout. That braided steel hose under the sink? At 120 psi, a small weak point doesn't create a drip. It creates a geyser capable of dumping hundreds of gallons of water per hour. Imagine that happening at 2 a.m. on a Saturday. By the time anyone discovers it, you're not dealing with a plumbing repair. You're dealing with a full-scale flood restoration, complete with drywall replacement, mold remediation, and ruined assets. So, how do you fight an enemy you can't see? You don't fight it. You manage it. You get ahead of it. This isn't about luck. It's about strategy. Your first move is reconnaissance. Get your water professionally tested. Don't guess. You need to know exactly what you're dealing with. What's the hardness level? What's the peak? Are there other corrosive elements present? This data is the foundation of your entire defensive strategy. Once you know the enemy, you can choose your weapons. If you have hard water, the solution is a commercial-grade water softener. This isn't a luxury. It's essential asset protection. A softener uses a process called ion exchange to remove the calcium and magnesium before they ever enter your plumbing system. The scale buildup stops. Your water heaters and boilers operate at peak efficiency. The lifespan of every water-using appliance in your building is extended. The return on investment isn't just in preventing a flood. It's in the daily savings on energy and the thousands you'll save by not having to prematurely replace critical equipment. If your water is acidic or has other chemical issues, you'll look at water conditioning or filtration systems. There are systems that use a neutralizing agent to balance the pH, stopping corrosion in its tracks. Again, this is about treating the cause, not just patching the symptoms. Next, you must control the pressure. Every commercial building should have a pressure regulating valve, or PRV, installed where the main water line enters. This device is the gatekeeper. It takes that high fluctuating pressure from the city main and throttles it down to a safe, consistent level for your entire building. But here's the critical part most people miss. A PRV is not a set-it-and-forget-it device. They can fail, they can drift out of calibration. Your maintenance plan must include checking the building's water pressure, at least annually, and adjusting or replacing the PRV as needed. It is one of the most important and most overlooked pieces of preventative maintenance you can perform. For an extra layer of defense, consider installing water hammer arresters. These small devices absorb the hydraulic shock that happens when a valve closes suddenly, preventing that shuddering bang in your pipes that sends a damaging shockwave through the entire system. Finally, this brings us to the end of our guide, and to the single most important principle that underpins everything we've discussed across all 10 parts of this series. From grease traps to sewer lines, from flood prevention to the invisible chemistry of your water, the lesson is the same. You can choose to be proactive, or you will be forced to be reactive. The plumbing system in your building is its circulatory system. It is the silent, essential network that keeps your operations alive. And like any critical system, it requires more than just emergency repairs. It requires a health and wellness plan. A plumbing disaster is rarely a sudden, unpredictable event. It is the final catastrophic symptom of a long-neglected problem. The grease that was allowed to accumulate, the tree root that was ignored, the corrosion that was left unchecked, the pressure that was never managed. These disasters don't announce their arrival with a thunderclap. They whisper warnings for weeks, months, or even years. Your job as a building owner, as a facility manager, as a steward of your business, is to learn to listen. To walk your property not just looking for what's broken, but looking for what's at risk. To shift your budget and your mindset from a reactive fix-it fund to a proactive prevent-it investment. Create a plan. Schedule your inspections. Test your water. Know your system. Partner with professionals who don't just fix leaks, but who help you build a strategy for reliability and resilience. Because the cost of maintenance will always be a fraction of the cost of a disaster. The water in your pipes can be the lifeblood of your business, or it can be the source of its ruin. The choice is determined not by chance but by the actions you take starting today.